Hello, how you doing? Do you know the difference between RAG versus ReAct? Well, if not, then watch along with me for the next few minutes, and I will quickly get you up to speed. Okay, let's get started. Let's first review RAG. Retrieval-Augmented Generation, or RAG for short, combines a large language model with an external data source, typically a vector database, enabling the RAG-driven system to retrieve relevant information in real time to generate more accurate and context-specific responses. This approach avoids having to modify the LLM itself with additional fine-tuning, making your system dynamic, cost-effective, and adaptable to new information. In this RAG-based system, you see that our vector database containing the embeddings, which are just vector representations of our data, is integrated into the overall system. So let me step through a flow for a typical user query in a RAG-based system. First, the user sends a user prompt to an LLM. The user prompt is submitted to an embedding LLM, which generates a query embedding. The query embedding is nothing more than a vector representation of the text in the user prompt. The RAG system uses this query embedding to perform a similarity search on a vector database. Semantically similar documents are returned from the vector database and then paired back up with the original user prompt and sent over to the LLM. The LLM tokenizer converts both the user prompt as well as the semantically similar documents into tokens. The LLM uses both of these to generate a response. The response embedding from the LLM is converted to output tokens, and from there, the output tokens are converted back to a user response. Now, let's quickly review a typical ReAct agentic system. Let me start with a simple flow for this ReAct system. In this diagram, we first see the user is prompting the ReAct system. Next, the LLM, which is part of this larger ReAct agentic system, takes the prompt from the user. If it can generate a final response, it does. But if the LLM does not have the necessary information, it checks to see if there's a tool within the larger ReAct system that can help it get the right information. If the LLM determines there is a tool available, it directs the ReAct agentic system to invoke the tool. In this case, the ReAct agentic system invokes the tool. Next, the ReAct system observes the results received from the tool. The observed results are then passed back to the LLM. At this point, the LLM reasons through the results. If the LLM still needs more information, it can direct the ReAct system to call another tool. Otherwise, if the LLM can determine the final answer with the results from this first tool call, it generates the final response. This final response is then returned to the user. The ReAct agentic workflow uses the LLM and available tools to alternate between reasoning and action. Let's compare 5 aspects of RAG versus ReAct. The first aspect is what is the primary focus for each of these patterns? Well, RAG is about augmenting the user prompt with additional factual knowledge, which is typically either up-to-date information or domain-specific knowledge within your business or organization. Alternatively, ReAct's focus is on multi-step reasoning and decision-making. The second area of comparison is the preferred use case. RAG is preferred in knowledge-intensive, static prompts to an LLM. ReAct is better for dynamic, interactive problem-solving that requires ad hoc reasoning and actions. A third area of comparison are the challenges for each of these approaches. A challenge for RAG is that it requires robust retrieval and indexing. Typically, this is solved using a vector database with strong support for similarity searching. Alternatively, ReAct requires reliable tool integration. The tools used in the ReAct system must be highly available and consistent, so the overall system is reliable. The fourth area of comparison is response accuracy. For RAG, response accuracy is high if the vector database data is accurate and up-to-date. For ReAct, it depends on the reasoning quality of the LLM used in the implementation. Not all LLMs are able to reason as good as others. The fifth area of comparison between RAG and ReAct is latency. For ReAct, there is an amount of latency introduced since there's a vector database retrieval step introduced into the prompt request response lifecycle. For ReAct, there's actually a higher amount of latency introduced as the LLM in the ReAct agentic system must execute multi-step reasoning. Additionally, invocation to tools that make external API requests also introduce additional latency. So when should you use RAG? Well, you should use RAG when you need reliable, factual answers derived from a vector database. RAG works well when the use case involves well-defined, knowledge-based queries. So when should you use ReAct? Well, you should use ReAct when you require reasoning over multiple steps or need the LLM to interact with external tools such as API calls dynamically. ReAct works best when the use case involves exploratory or dynamic workflows without a predefined knowledge base. So now you should have a good, high-level understanding of the differences between RAG and ReAct. You should also understand the types of use cases when each of these approaches works best. Okay, thanks for watching. This video, along with all the other videos in this playlist, are listed in the YouTube description. I invite you to watch other videos on my channel. If you like the way I'm sharing this content, please consider subscribing. When you subscribe, this really helps my channel grow. One last thing, we all love technology, and we're all excited about all the innovation with the cloud, machine learning, AI. But don't forget to carve out some time to live in the real world. Go outside, go swimming, go hiking, go climbing, go surfing. But get out and move your body. And if you do, let me know in the comments. I want to hear about that too. And with that, have a great day.